Hi everyone, today I want to talk about perseverance, but not working hard. Instead, I want to talk about the Mars rover that NASA just put on the surface of Mars a couple of weeks ago and is now ready to start full scientific experiments. And for the purpose of this, I've invited my special guest, Newton. After being named after a famous physicist, I thought we'd explain this one together. So, we've been going to Mars for a while now, of course, but what's the purpose of this Perseverance mission? Well, there are two principal purposes. The first purpose is to try and discover if there is any evidence for life. Seems like we've always been trying to do that, but this is a very specific remit this time in how we might actually achieve that. And the second is to try and pave the way potentially for human missions or even potential colonization of Mars. So let's delve into these two objectives a little bit more and understand some of the science behind them. So the first mission objective, is there life on Mars? Something we've been trying to figure out for a while now, and generally the approach has been follow the water, given that water on Earth is a necessary precondition to all forms of life. And that actually influenced the choice of landing location for the Perseverance rover, the Jezero crater, which looks like it could have been in the past the location of a very massive lake. Now, we actually already know that there is water on Mars, so this doesn't need to be confirmed. We know that at the poles there is ice. We're also pretty confident that there's water underneath the surface of Mars, and there is also water vapor in the air. So what will happen this time? However, what the Perseverance rover will do this time is take soil samples, and they're kind of like cigar-shaped samples that would be left on the surface of Mars for a future Mars return mission to take those samples back to Earth for analysis in Earth-bound laboratories. The reason being is that we can get a much closer reading from Earth laboratories about, for example, whether there are any ancient microbes or other forms of life beneath the surface of Mars. Now, the rover won't randomly go and select like a bunch of samples on the Martian surface. There are actually numerous instruments on board that help the rover select what might be the highest probability areas for growth. There are X-rays and so on and so forth. And so these machines, when used together, can actually detect the potential for organic molecules beneath the Martian surface. And where the organic molecule probability is relatively high, the rover will take a sample. There is also an instrument on the rover that will do a high-resolution mapping of the subsurface water on Mars, which may be a very important part of future missions or colonization, because of course we need water to survive. Which brings me on to the next big task for the Perseverance rover, and that is to try and produce oxygen from the Martian atmosphere. So how do you produce oxygen on Mars? Well, the Martian atmosphere is 96% CO2. So it's not breathable. It's only 0.13% oxygen. So if we were ever to colonize Mars or support long-term missions on Mars, one of the key things would be to get that oxygen produced. Now, the Perseverance rover has an instrument called MOXIE, which is designed to produce that oxygen from CO2. Now, how does this work? So the MOXIE apparatus works by a process called solid oxide electrolysis. Well, what actually is that? Well, what happens is there's a catalyst operating at around 800 degrees Celsius. The CO2 comes in, and at this temperature that catalyst rips off one of the oxygen atoms, producing an ion and then carbon monoxide coming out the other end. As more and more individual oxygen atoms or ions are produced, they combine to form the diatomic oxygen, the O2 that we breathe. And that's the process by which you would convert CO2 to O2 and CO coming out the other end. This is a process that works pretty well on Earth, so it is expected that it will work quite well on Mars. The issue is, of course, though, that it doesn't produce that much O2. At the present, it's not a very efficient technology, so maybe it would have to be significantly upgraded to support an entire human settlement. But it would nevertheless be quite exciting to understand that yes, we can create our own machine to help support breathing of a natural atmosphere on the surface of Mars. As well as these two principal objectives, there's kind of a bonus one as well. The first helicopter ride on Mars, or well, at least a small drone. Now, drone flight or helicopter flight on Mars is pretty tricky because the Martian atmosphere density is only about 1% of that on Earth, and therefore getting the upthrust not so straightforward. So at the minute, or at least in the future, it's anticipated that most distance travel on Mars would be by rocket propulsion, which of course requires fuel, oxygen, etc. So if you could actually get a small helicopter drone going, that could be pretty interesting for future manned missions. And as a result, you'll see in the next few days, hopefully, the very first potential helicopter flight on the surface of Mars. So there's a lot of great science that's going on, some very potentially groundbreaking discoveries that could be made, but for the time being, I just invite everyone to look at these stunning pictures that the Perseverance rover has set back and really imagine that here you're seeing just beautiful images of one of our closest neighbours, and maybe one day we'll actually have people on there too.